So today I would like to talk a little bit about my master's thesis project and one specific aspect of my master's thesis project at Western Colorado University. And I'd like to talk about characterizing the historic fire regime of the Upper Gunnison Basin today. So fire is an important ecological process. It recycles nutrients, fire regulates organism traits, regulates population sizes, and it's really important that we're able to understand fire in a way that we can classify it and characterize it. And the way we can do this is through fire regimes. So there's three characteristics that make up a fire regime, and that's climate, ignitions, and vegetation. We can also describe fire regimes through severity, intensity, seasonality, and frequency. So historic fire regimes can be very helpful. With increasingly hot conditions, increasingly dry conditions, fire has become a big topic for land managers, as we're just seeing record fire years year after year after year. And it's important that we understand historic regimes to help us, to inform us on how we can move forward with fire and how we can plan for the future in an increasingly hot and dry climate. So here you'll find two plant species. On the left, there's ponderosa pine, Pinus ponderosa, and on the right is Douglas fir, Pseudotsuga menziesii. And what these two tree species have in common is that they've both evolved to withstand high frequency, low severity fire. What I mean by that is that they have really thick bark and they do self-pruning their lower branches. So you can see here, the bottom of this ponderosa pine tree has no branches, and that's because it's self-pruned so a fire doesn't reach into the canopy and kill the tree. When I talk about severity, I talk about reference to plant mortality. Intensity refers to how hot a fire is, but severity is a reference of plant mortality. And these forests the forest floor of these forests are dominated by fine grassy fuels, a lot of the time the Arizona fescue. And this characterizes that high frequency, low severity fire. Why are fire regimes changing? Why are they changing the Rocky Mountains? So I have this figure here again. So a change in any one of these characteristics is going to alter that fire regime, change in climate, ignitions, or vegetation. So the first change in fire regime I want to talk about is livestock grazing and fire suppression. So I have three pictures here that I got from Smith and Arno, 1999. It's the same forest at three different time periods. So you can see in 1909, this ponderosa pine stand was really open, definitely characterized by that fine grassy fuel, that Arizona fescue. 1958 gets a little bit more crowded, a lot of sapling growth, some shrubs. 1989, it's just a thick mess in there. And the reason for this is the introduction of livestock grazing in the late 1800s, and this altered the vegetation characteristic of a fire regime. And what this did is it got rid of those fine grassy fuels, and those ponderosa pine stands. And what happened is made those fires a lot less frequent, but when they did burn, you could see all the shrub growth. There's a lot more fuel there for that fire to burn hot, and those fires are much more likely to burn up into the canopy and be a high severity standard placing fire. Climate change and fires. So climate change has also drastically affected fire. You can see this picture is a result of the endemic conifer bark beetle that has increased in incidence over the last 25 years because of the hot and dry conditions, which they really like. So here we have a change in climate affecting the fire regime. Climate change also has extended the fire season by quite a bit in the summer, and has increased the amount of dry fuels that are out there for fires to burn. Climate change has also declined forest resilience. Forests are less likely to recover after a fire, and we're seeing more convergence to non-forest types after a fire. So now let's get back to characterizing these historic fire regimes. So on the right here, you'll see a cross-section of a Douglas fir tree that I sampled at Sapanero Mesa. And these are the scars, these are the fire scars here. And you can see the rings are curling over the scars, and that's the tree healing over those fire scars. And notice all these little ringlets too. This tree has withstood quite a few fires in its lifetime. So what we can do, we can use dendrochronology to date these fires. And it's really easy if we sample a living tree because we just count back from the last ring because that was the last year until we get to the fire scar, and then we can date what year that fire happened. But if we sample the dead tree, we don't know when that tree was born or when it died. So what we have to do is we have to use dendrochronology to find known climate patterns in the tree rings, like fat, skinny, skinny, fat. We know, okay, that's a wet, dry, dry, wet year. That was, 1888 or whatever, and then count back from there until we get to a fire scar, and then we can date that fire. So here's some more pictures of some fire scarred stumps and trees. You can see the tree healing over that scar. Here's a cool one where the tree actually completely healed over the fire scar. So thus far we have 177 samples from 111 trees. We're going to spend a lot of time this winter processing and dating those fire scars. And here's a map of the upper Gunnison Basin. Here's Gunnison, Crested Buttes up here. You can see we've got a nice good distribution of established sites across the basin. And within each of these sites, we need 10 trees to sample within a 1 hectare area. That's the ideal. And the reason for that is the 1 hectare area is making sure that we're capturing one fire regime in our data, and the 10 samples is to ensure that we're not just getting a few lightning scarred trees, that we're actually getting some fire scars in that data. So future implications for the project, we want to see how fire affects sage-grouse habitat, how fire affects sagebrush. So what we're going to do is we're going to find ponderosa pine stands with sagebrush in between them that have synchronous fires. And we're going to make the assumption here that that fire moves through that sagebrush, and that sagebrush burned at one period in time. And we'll do some vegetative surveys. We'll do some cross-section and dating of that sagebrush to see how that sagebrush habitat was affected by that fire. And we'll also do the same with ponderosa pine stands that did not have a history of fire, and we'll see how does the adjacent sagebrush look in those systems as well. Lastly, I'd like to acknowledge the USGS, Alice Margolis, Emmanuel Lopez, Brian Stevens from the BLM, and Western Colorado University, including Dr. Jonathan Koop and my peers in faculty that have been so helpful throughout this process.